Today we will continue with quadratic equations and expressions, lecture number 6. Now till last lecture you have learned what is quadratic equation, how to find roots, if roots are given how to find equation, and then you have learned completing square method also, and after that we have learned nature of roots, properties of roots, and using these we also solved lot of questions, and then we continued with transformation of roots. That is, if pattern of roots is given and it is found to be common, how to use a different technique to find the equation. So after that we have also learned what is quadratic expression, what is input, what is output, how to draw the graph, how to find the minimum value, maximum value of simple quadratic expressions. Now in today's lecture we will learn a different technique of handling ratio of quadratic expressions. So if there is a function, for example here, if there is any function which is a ratio of quadratic expressions, how to find the range of such functions. Now in general when it comes to ratio of polynomials, these are also called as rational functions. Now using the graphs of rational functions we can also find the range of such functions, but that we will learn when we learn rational functions in the chapter functions. So today we will focus mainly on the questions which are of simple quadratic by quadratic pattern and using the technique of only the quadratic. Okay. So how to proceed? First I will explain the technique and then I will explain the rules of the technique. Okay. So first is we take the function and we equate it with y. For example, let us say I have taken the first question. So here we have x square plus x plus 1 divided by x square minus x plus 1. This is my function. I equate this to y and then I convert this into an equation which is quadratic and which is in terms of x only. So how do we do that? We cross multiply this. So what do we get when we cross multiply? So the terms in RHS will look like y into x square minus y into x plus y. Now take all terms to LHS and club the terms based on the powers of x. So suppose if I take x square common here, so what are the terms that I will get? 1 from here and y from here. So it will become 1 minus y. Similarly, when I take x common, so I will get 1 from here and y from here. So we get 1 plus y, and similarly the constant term which is 1 minus y equal to 0. So this is a quadratic equation in terms of x. Okay. Now further, after this what is our main goal? Our main goal is to find the values of y, basically range of values of y. So how to proceed from here onwards? To understand this you need to understand the basic concept of quadratic functions. Suppose here if I name this quadratic, if I name this function as let us say f of x, that means this is equal to y. So basically this function f of x is giving an output y when I give an input x. Okay. So in general nature of function is like this. Now all functions that we study at 11th and 12th standard are basically real valued functions. It means for real input we should get only real output. Now if you reverse this picture and try to understand, that means if I give x as input I will get y as output, but both are real. Now reverse this. So that means if you give y, can we get x? Of course we can get x. So that is exactly the idea on which we are going to base the entire analysis. Okay. So imagine this quadratic equation. Suppose if I put y equal to 3 and solve for x, I should be getting real values of x because only real inputs give real outputs. So if I fix output y and solve for x, then the values that I should be getting in terms of x should be real numbers. Excuse me. So if I fix y and solve for x, the values of x that I should be getting must be real numbers. Okay. So that is the idea that I am applying here. So assuming that I am fixing y, if I solve for x, my values of x should be real. So I will put the condition that delta must be greater than equal to 0. What is delta? It is the discriminant. Now this is the main crux of this method. If you understand this step, then that means everything is just done there itself. Okay. So delta means b square minus 4ac. So let us solve it first, and then I will come back to this and I will explain one more time. Okay. So now 1 plus y is basically b. So we will be getting 1 plus y whole square minus 4 into 1 minus y, 4 into a into c into 1 minus y. This must be greater than or equal to 0. Now if I simplify this, I will get one quadratic inequation in terms of y. We know how to solve it. We can solve it using wavy curve method. Okay. So let us first solve this till we get the answer. Now this means if I simplify this, I will get 1 plus 2y plus y square minus, here it is 1 minus y whole square only. So that will be like 4 into 1, that will be minus 4, 4 into y square minus 4y square, and the 2ab term which is minus 2y into 4, that becomes 8y. So this must be greater than equal to 0. Now let us simplify this. There is 1y square, there is minus 4y square, so it gives minus 3y square, and y terms are 2 terms, so that gives us 10y, and there are constants here, minus 3 greater than equal to 0. Now if I want to keep my leading coefficient to be positive, I have to multiply with minus sign. If I multiply with minus sign, I have to change the inequality also. Okay, so if we multiply with minus sign here, the inequality will get reversed. So it becomes less than equal to 0. Now if we factorize this, because 3 into 3 is 9, 9 into 1 is 9, so 9 plus 1 is 10. So I think factors are very simple factors. So 3y here, y here, so we need 1 3 here, so 3 minus minus 1, I think these are the factors. Okay. So this must be less than equal to 0. So this means we can solve this using wavy curve method, 3 here, 1 by 3 here, plus minus plus. So y must be belonging to 1 by 3 to 3 closed interval. Okay. So we got one set of values. Can we conclude that this is going to be range? No, we can't. We have to explore one more case. What is it? The one more case should start from here. Coefficient of x square is 1 minus y. If this coefficient becomes 0, if 1 minus y becomes 0, then the entire analysis that we have done, that discriminant must be greater than equal to 0, this will fail. So naturally we should be putting a condition that 1 minus y is not equal to 0. We should be putting a condition like this. Yes, do you agree with this? Not so fast. We have to verify if y is equal to 1 or not based on this function. We need to verify that also. If that verification is done, then we can conclude about range. Okay. So now before we go further, I will explain this one more time. If coefficient of x square is equal to 0, then our entire analysis will go wrong. So for that we need to exclude this y equal to 1. But are we sure we want to exclude? No, because the main function is not a quadratic function, it is a rational function. So there could be a situation where this output is going to be 1. It is possible. So we have to explore that possibility once. So how do we do that? We equate this function to 1 and we check if there is any real value which will satisfy it. Okay. So for that what we do is we equate this directly to 1 and check. So x square plus x plus 1 by x square minus x plus 1, this is directly equated to 1 and it is solved. So what do we get here? X square plus x plus 1 equal to x square minus x plus 1. x square gets cancelled, 1 also gets cancelled. So, we get 2x equal to 0, which means x is equal to 0. So, we got a value which is x equal to 0 and we put it here and see. Is x equal to 0 a valid input? How do we check that? Is there any situation of 1 by 0 or 0 power 0? We have to check for mathematical threats. So, here x equal to 0 is a perfectly valid input for this function. So, that means y equal to 1 is possible. So, we cannot put this condition. But in some situations that condition is valid. Some situations it is not valid, in some situations it is valid. You need to verify that situation. So, hence this workout. So, this means y equal to 1 is accepted solution. In some books for the same problem, the answer is written as 1 by 3 to 3 excluding 1. In some books it is written like this, but this is wrong, this is right. Okay. So, now let us go back to the overall overview of this question. There is a function which is ratio of quadratic. We equated that to y and we simplified. So, here we are analyzing like this. If I fix y and solve for x, I should be getting real values of x. Okay. So, now after we got the answer, let me explain one more point. So, let us take one value which is not in the range. Okay. Suppose let us say I take y equal to 5. Okay. So, let us say I take y equal to 5 and then I solve this question. So, what do we get? I will do it here. So, if I take y equal to 5 and solve this. So, x square plus x plus 1 by x square minus x plus 1 equal to 5, and if I solve it, what do I get? X square plus x plus 1 equal to 5x square minus 5x plus 5. Now, if I simplify, I will get 4x square minus 6x plus 4 equal to 0, which is also same as 2x square minus 3x plus 2 equal to 0. Now, if I check the discriminant of this, it will be minus 3 whole square minus 4 into 2 into 2, which is a negative value. You see what has happened here? If I had taken any value which is not in the range, discriminant is coming out to be less than 0, which is actually violating our this condition, which means whatever we did is right. Now, on the other hand, what did we discuss in the initial step? If x is real, y should be real. Now, if I fix y, solve for x, I should be getting real values. If I fix y to be 5 and solve for x, I am not getting any real values. It means that particular y is not in the range. Okay. So, if I fix y to be 5 and solve for x, and if I do not get real values of x for that y equal to 5, it means there is no x which will give me that y equal to 5. So, that means 5 is not in the range. Okay. So, this is logical explanation for this method. I hope you have liked the method and also the explanation. Okay. So, definitely take a snapshot of this page and also the next page. This page also. Okay. So, this way we can solve the problems. I hope you have understood the entire method. Now, we will quickly solve the other questions very fast. Okay. So, let me just erase the entire ink and also in the next page. Now, I have solved this first question, I will solve the second question. So, what is our method? Equate this to y and solve it. Okay. So, x square minus x minus 2 by x minus 1 is equal to y, and then we cross multiply and simplify. So, what do we get? X square minus x minus 2 equal to yx minus y. Now, when I take all terms to LHS, so what do we get? X square minus x into 1 plus y minus 2 plus y equal to 0, and our discriminant must be greater than equal to 0, which will give us one condition that 1 plus y whole square, because there is minus 1 plus y whole square, it is same as 1 plus y whole square, minus 4 into 1 into y minus 2 must be greater than equal to 0. Now when I simplify this, what do we get? I get 1 y square from here, and there is one 2y from here, there is one minus 4y from here, so minus 2y, and there is constant 1 here, there is constant plus 8 here, so I will get plus 9 greater than equal to 0. Okay. So further, what is the next step? Solve this and find the solutions of y. So here, what are the values of y that we get if we just go by a formula method or something? So what is the value of y that we get? It is 1 plus minus 2 root 2, right? Okay, yes. No, but there is one I also here, which is actually creating the problem. So here, the roots of this quadratic are actually complex, which will make our job even more easier. Why? Because if I, let's say, add here, let's say if I add 1 here and subtract 1 here, so what do I get? I get y minus y whole square plus 8 is greater than equal to 0. So you look at this statement, y minus y whole square is already a non-negative term. So if I add 8 to it, then definitely this entire number is greater than equal to 0. So this statement is already valid. So y must be belonging to all real values. That is what we have got from this statement. Okay. Now on the other hand, if we look at this quadratic, let's say, let's take this as f of y is equal to y square minus 2y plus 9. The coefficient of the highest power is 1, which is positive, and our discriminant is negative. So the graph of y versus f of y is going to be completely above x-axis, which means no matter what value of y I am putting in this function f of y, output is going to be always positive. So that means this discriminant greater than equal to 0, this condition is already satisfied, which means y must be belonging to all real values. Now can we say that the answer is y belonging to all real values? No, not so fast. Why? We have to still verify that statement, which is leading coefficient equal to 0 or not. So now in this equation, if we observe, leading coefficient is already 1, which is already not equal to 0. So there is nothing much to verify here. So hence this is correct answer. So even though it is correct, at every step it's your job to verify if it is right or not. Okay. So this way we can solve the second question. Okay. So in fact, second question also can be solved using graphs of rational functions that you will anyways learn in functions. Okay. So quickly take a snapshot of this. Okay. So now we will move on. Now in the next question, we have done first and second. In the next question, it should be the same method that you should be following. So hence I am not doing this. Okay. But if you want, you can explore this. Okay. But there is some glitch here. One is there is an error here. This must be 4. The other is this. Suppose let us say we have factorized it. So what are the factors we get? There is x minus 1 factor here, and there is x minus 4 into x minus 1 here. These are the factors. So x minus 1 is a factor which is actually getting cancelled. So this looks like a simple polynomial by polynomial type function, which is also linear by linear type. Okay. X minus 1 can get cancelled. But if you, let us say, assume that x minus 1 is not getting cancelled and solve this problem, you will still get the range. Okay. So that is the main idea of this problem. Okay. Suppose let us say I solve this quickly and explain it completely, it is better that way. So we equate this to y and simplify. Okay. So x square minus 4x plus 3 by x square minus 5x plus 4 equal to y. Let us say we are solving this in the same style. excuse me. So what do we get? Here x square into 1 minus y and here x into 5y minus 4 plus 3 minus 4y must be equal to 0. I have basically simplified it. Now further our delta must be greater than equal to 0. This implies 5y minus 4 whole square minus 4 into 3 minus 4y into 1 minus y must be greater than equal to 0. So let me simplify this. We get 25y square here and we get 4y, y and 4 here. So we are getting minus 16y square. So we are getting 9y square. Okay. So I am just fastening this simplification process. And when it comes to 2ab term, so 4 into 5 is 20. So here we are getting minus 40y and here minus 4y and minus 3y. So minus 7y into 4, that will be 28y. So plus 28, minus 40 plus 28 is minus 12, minus 12y. And next there is 16 here and here constant term 1 into 3 into 4, which is going to be 12. So 16 minus 12 is going to be 4, greater than equal to 0. So here this turns out to be a perfect square. Okay, very nice. This turns out to be a perfect square. So we know that every perfect square is always greater than equal to 0. So this condition is already satisfied algebraically. So we can say that y belonging to all real values are the solutions of this condition. Now can we say that the range of this function is all real values? No, not so fast. What is our step that we have to check? We have to check if this 1 minus y is equal to 0 or not. Okay. So for that we equate this function to 1 and check. So basically we are verifying this statement. Okay. So how do we do that? We equate this to 1 and verify. Okay. So what do we get here? X square minus 5x plus 4 is equal to x square minus 4x plus 3. X square is getting cancelled. If I take minus 5x to that side and 3 to this side, so we get 4 minus 3 equal to 5x minus 4x, which is giving me x equal to 1. But is x equal to 1 a valid value here? So here if you check, x must not be equal to 1. It's given in the question, but it need not be given. Here also if we check, denominator cannot be 0. So here naturally x not equal to 1 and x not equal to 4 are the natural conditions. So when we assume that 1 minus y is equal to 0, what were the cases we got? We got x equal to 1, which is an invalid input. So hence y cannot be equal to 1. So hence set of all real numbers is not the range. We have to remove 1 from here. Okay. So this way we can keep our process in check with our analysis and our algorithm. Okay. So I hope you have liked this method. So definitely take a snapshot of this also. Okay. Now, if you go by the other way, let us say if you cancel these two. So let me write that in red. Let us say if we cancel these two, we get a function which is x minus 3 by x minus 4. This can be handled just like the way we handle this function y equal to 1 by x, and graph through graph we can get the range of this function. That is also possible. But let us leave that for the functions. Too much of inducing knowledge is also not good at once. So we will learn everything step by step. Okay. So now here there is one natural condition that you need to understand here also. Okay. So that condition is this. So we can apply this method only if these rules are satisfied. Okay. So first rule is our denominator must not be equal to 0. If denominator becomes equal to 0, then that means we are entering into a domain where we are handling not defined values. So, that is definitely avoided. Second is, this method will give us values, it will give us solutions only if x is varied indefinitely over all real values except these values, okay, except where denominator is equal to 0. So, that means x must be a variable which is varying over all real values indefinitely, that means without any condition. But if I put any condition that x is greater than 0 or let us say x is belonging to 1 to 10 or something, then this method will fail. But then what to do? We have to borrow some techniques from the chapter functions, okay, or maybe we have to borrow some concepts from other standard ideas. We will see one or two such examples in today's lecture, okay. So, this is the overall idea of this approach, and to identify, to analyze, to plan and to execute. These are the steps that you need to master when it comes to finding range of functions, okay. So, quickly make a note of this, we will move on to the next question. So, let us say there is this question. So, here it says if this function, so we generally take an expression as a function. So, if this takes all real values, find the interval of a. Now, what is the meaning of this? Takes all real values. So, whenever we talk about any function, let us say f of x. So, you remember that input is a real number, output is also a real number. So, whenever we are talking about any function, we are basically talking about a function which is mapped from real values to real values. So, if I say this statement, x takes all real values, it means from the set of inputs, input x is taking all of them. Now, if I say f of x takes all real values, it means from the set of outputs, it is taking all real values. So, it means if function takes all real values, it means range of function is going to be all real values. Now, sometimes we also see this phrase assumes, okay. So, in general question also comes like this, f of x assumes all real values. It also means the outputs are going to be landing up on the values which are all real values, okay. So, when we do this mapping, so this entire set is mapped, so that means it is going to assume every value of this set, okay. So, here I have explained the phrase with more details and clarity. Now, let us attack this question, okay. So, to solve this question, what is our method? Method is going to be same. What is it? Equate this to y and apply the same method and see what happens later, okay. So, suppose let us say I equate this to y. So, x minus a equal to y into x square minus 4x plus 3, this is what we got, and when I simplify this, I get x square into y, and when I take the coefficient of x, so I am taking everything to RHS here. So, here there is minus 4y and here there is 1, so it becomes minus 1, and now the constant terms. So, here it becomes 3y plus a, this must be equal to 0. Now, when I apply this condition that delta must be greater than equal to 0. So, what do I get here? I get minus 4y minus 1 whole square minus 4 into y into 3y plus a. This must be greater than equal to 0. Now, we have to simplify it in the regular manner. So, here there is 16y square plus 1 and plus 8y, and here 4 into 3 is 12 minus 12y square minus 4ay. This must be greater than or equal to 0. Now further if I simplify, what do I get? 4y square, and if I take y common, I get 8 minus 4a. And what are the constant terms here? There is only one constant term, which is 1. This must be greater than or equal to 0. Okay, so have we done everything correctly here? Okay, so it seems so. Now, the solutions of y that are going to come after this step are supposed to be the values of range. But in the question claims that all real values must be the range, which means this condition must be satisfied for all real values of y. But when we solve this inequality, we should be getting a limited interval or limited values, but question claims that it is still all real values. So then that means this quadratic expression, if we draw graph, it must be completely lying above x-axis. Okay, so for example, if we just observe this with respect to, let us say there is y here, this is the input and this is the output, which is f of y. So the graph must be either of this shape or of this shape, where discriminant is negative here and discriminant is equal to 0 here. Okay. So for any quadratic expression to be always non-negative, what is the condition? Discriminant must be less than or equal to 0, along with there is another condition. So for this type of parabola, coefficient of the leading coefficient, that is the coefficient of y square, must be positive. So here if I observe, coefficient of y square is already positive. So that means I just need this condition, which is delta less than or equal to 0. Okay, because 4 is already greater than 0, we don't have to solve this condition. Okay. So now further, if we solve this condition, we will be getting required values of a. Okay. So here if you notice, we have applied the concept of this determinant once here. This is one checkpoint. We have also applied the same concept again here, but in a different manner. So if you notice, there could be a question where this concept is used more than 2 times also. These kind of questions are naturally possible when it comes to IIT exams. Okay. So probably in mains and CET, the questions generally stop at only one application of this, but later on this question could lead to many other possible questions also. So what happened here is, this led to a question, we solved it, and again it led to another question. So that also we will be solving in the next page. So for this also discriminant must be less than or equal to 0. So let us just solve that. So here 8 minus 4a whole square minus 4 into 4 into 1, this must be less than or equal to 0. Okay. And here luckily this 4 is getting common. So that means 4 square I can take common from the entire expression. So I am getting a minus 2 whole square minus 1 must be less than or equal to 0. So either we factorize it and solve it, or we can directly also solve it using basic ideas. Okay. So here if I just factorize this, I get these factors: a minus 3 is 1, a minus 1 is 1, less than or equal to 0. This term is already greater than 0, so we don't have to handle it, we just have to handle this. So this will give me solutions from minus infinity to 1, closed on 1, and 3 to infinity, closed on 3. Okay. So this we got by wavy curve method. Okay. Wait a minute, we need less than or equal to 0, so this is wrong. So what are the solutions? Solutions are from 1 to 3. Okay. So here if you analyze, for these values of a, our discriminant of this expression is always less than or equal to 0, which means this expression is always greater than or equal to 0, which means for all values of y which are real, that means for all y belonging to R, this condition is always satisfied, which means the range of this function is all real values. Okay. So here we have analyzed and we have solved this question in a very much clear manner. Okay. Come on, take a snapshot of this also. Okay. So, when it comes to this inequality, there is also another way here which I was mentioning. We can also solve it directly, because a minus 2 whole square must be minus 1 must be less than equal to 0. So, a minus 2 whole square must be less than equal to 1, which means a minus 2 must be between 1 and minus 1. Based on this idea also we can solve it. So, if we just add 2 on both sides, we will be getting a belonging to 1, 2, 3. Okay. So, whichever method you are comfortable with, you can solve it. It is just matter of time and matter of comfort. Okay. Now, can we move on to the next question? Okay. So, this also is based on the same idea. Okay. So, this takes all real values, find the real values of a. So, what do we do? Same process. Okay. So, but here I will just speed up the process. So, we assume that this is equal to y, okay, and we simplify this. So, x square plus 2x plus a is equal to x square plus 4x plus 3a into y. Now, we take either LHS to RHS or RHS to LHS, it does not matter. So, x square into y minus 1 plus x into 4y minus 2 plus 3ay minus a, this must be equal to 0. So, further delta must be greater than equal to 0. So, here I already see a factor which is 2. So, whenever I am applying delta, because it is b square minus 4ac, in 4ac term there is already 4. So, if b is even, I am actually looking for taking 2 common here to speed up the algebra. So, if I take 2 common, it becomes 2 square, and what is remaining here? 2y minus 1 whole square minus 4 into, here there is y minus 1 and here 3ay minus a. This must be greater than equal to 0, but y must be belonging to all real values, remember that. So, this 4 can be taken common because it is a positive number, so we can just omit it from the inequality. So, what do we get here? 4y square plus 1 minus 4y, and here minus 3ay square, and here minus 3ay, and there is minus 4a minus ay, which becomes minus 4ay, there is minus sign, plus 4ay, and the constant term 1 into a into minus 1, it becomes minus a greater than equal to 0. So, now if I take y square common, so I will get 4 minus 3a, and if I take y common, I will get 4a minus 4, and in C I have 1 minus a greater than equal to 0. Now, because we want this inequality to be satisfied for all real values of y, so that means there should be two conditions. One is this 4 minus 3a must be greater than 0, and the other is the discriminant of this must be less than equal to 0. So, why this case? We have explained it in the last case. Okay. So, with respect to y, if I observe the outputs of f of y, because it is a quadratic function here, the graph must be a parabola, and for all real values of y, it must be positive, non-negative. So, it must be either this graph or this graph. For this delta is negative and for this delta is equal to 0. So, we are putting both of them in one single condition. Okay. So, now we have to solve these two separately. So, there is 4 minus 3a greater than 0, which will give me a less than 4 by 3, and the next condition, what is it? Delta must be less than equal to 0. So, let me just simplify this. So, we get 4a minus 4, so I can write it as 4 into a minus 1, right, whole square minus 4 into 4 minus 3a into 1 minus a, must be less than equal to 0. So, now I can take 1 4 common, I can also take a minus 1 common. Okay. So, what remains here? I'll be left with 1 4 here. So 4a minus 4. And if I take a minus 1 from here, it becomes plus sign here. So plus 4 minus 3a, this must be less than equal to 0. So here this 4 gets cancelled and we got 1a here, beautiful. This inequality has become even simpler. So now how to solve this? You know this standard inequality. So a will be belonging to 0 to 1. Okay, so any mistake we have done? Okay, so far none. So a is belonging to 0 to 1, that means for all these values of a, these conditions are satisfied, but there is one more aspect that we have to observe here. So one more aspect is this: values of a must be less than 4 by 3. So here if we observe, values of a are already satisfying this condition, so hence all of them are valid solutions. But if there are any values which are going out of the boundaries, we have to break them and we have to cut them. Basically, when these two conditions are satisfied together at once, only then our required condition will satisfy. What is this? This expression must be greater than or equal to 0 for all real values of y. So for that purpose, we have to take intersection of these two solutions. Here it is a very simple form, so we directly wrote, but sometimes when intervals go really big or really confusing, we may have to draw number line and take the intersection, but you should be ready with it. Whenever you are solving a problem, anything can happen in it. It is an unknown jungle. You have to make it work out with all the tools and weapons that you have learned in your lectures. Okay. So quickly take a snapshot of this, we will move on. This page also. Okay, next. So next question is also of the same form. So I am skipping this question. You can take a snapshot of this and you can try to solve this question on your own. Okay. So can we move on now? Okay. So next question. This is a little different question, but an interesting question. So here a relation is given in terms of x, y and z, and we have to find the greater and least values of x. So before I proceed for the solutions, let us first observe the given conditions. Whatever is the form given in x, it is also the same form on y, same form on z. So if I get any minimum value for x and maximum value for x, these must be same for y also and z also, because there is algebraic symmetry in the given equations. Okay. So that means if I, let us say, swap x, y, y, z and z x, this is also sometimes called as cyclic swapping. Here you can also observe these two swapping. Okay. So there are two types of symmetry that I am talking about here. So now that I am discussing, I will discuss it in details. So if there are, let us say, two variables x and y, if I swap x and y, that means if I put y in place of x in place of y, and if the algebra remains same after this substitution, it means y and x will have similar nature and y equal to x could be a solution if it is a problem solving type case, or if it is generally analysis type case, whatever is the analysis you are getting on x, similar will be valid for y. Same goes for cyclic swapping also. That means if y is replaced with x, z is replaced with y, x is replaced with z, and if the algebra remains same, you try to substitute here and see, algebra will remain same, then that means the same analysis, x equal to y equal to z is a solution if you are solving it. If you are not solving it, if you are just analyzing for maximum and minimum values, then whatever is the analysis you are getting on x, same will be valid for y, same will be valid for z also. Okay. So this is one discussion on general knowledge. Okay. Now let us proceed with the question. So now when it comes to the question, how do we proceed with this? So let us take this idea. We know that x square plus y square plus z square is equal to 2 units. So, let me just put 2 here. Now, why did I leave gap? Because I am going to introduce these terms here. And suppose let us say I put here minus 2 into x plus y plus z. Okay. So, this means I am actually subtracting 2 into 2 here, because the value of this term is 2 units. Okay. So, now if I simplify this, what am I getting? X square minus 2x here, and y square minus 2y here, and z square minus 2z here, and in the RHS 2 minus 4 is going to be minus 2. Okay. Now, after looking at these terms, I am getting this idea that I will add 1 here. Okay. So, effectively how much did I add? I added 3. So, let us balance it here. Now, what do we get? If we club these 3, we are getting x minus 1 whole square. If we club these 3, we are getting y minus 1 whole square. If we club these 3, we are getting z minus 1 whole square. This must be equal to 1. So, here sum of 3 squares is equal to 1. All squares are positive numbers only. Okay. So, for any square here, suppose let us say I take x minus 1 square, the minimum value of this is 0, because we know that all perfect squares are always greater than or equal to 0. And what could be the maximum value? Because the other values cannot be negative numbers, they are also non-negative numbers. So, the overall value must be equal to 1, and we are looking for the maximum value of this x minus 1 whole square. So, when this is at its own maximum, the others must be at their own minimum. When others are at their own minimum, only then we will get x minus 1 whole square to be maximum. So, if others are at minimum, what could be that minimum value? Because they are also perfect squares, the minimum value of these must be 0. So, when these two are zeros, we will get the maximum value of this to be 1. Okay. So, here whenever there is a situation like this, let us say a square plus b square plus c square is some positive constant. So, here it is 1, so I am taking 1. So, we can say that a square is maximum when b square and c square are equal to 0, only then a square will become maximum. So, basically these must be at their own minimum. Okay. So, that is the idea that we are using here. So, now using this idea, this left hand side statement is naturally valid. So, if I just solve this inequality, so x minus 1 must be between minus 1 and 1. So, which means x must be between 2 and 0. So, what is the minimum value for this? For x 0, maximum value for x is 2. Now, as we have explained earlier also, similar analysis is valid for y, similar analysis is valid for z also. So, this way we can understand about x, y and z. Okay. There could also be a different method. For example, here I subtracted x plus y plus z 2 times, I can also add it. Okay. For example, same problem can also be proceeded using this idea, x square plus y square plus z square plus 2 into x plus y plus z. This must be equal to 2 plus 2 into 2, and we are adding 1 plus 1 here, which means we are adding 3 here. Now, if we simplify this, what do we get? X plus 1 whole square plus y plus 1 whole square plus z plus 1 whole square is equal to, how much is the value here? It is 9. And now, same analysis we can do one more time. So, x plus 1 whole square must be less than equal to 9 and must be greater than equal to 0. So, which means this x plus 1 must be belonging to 3 to minus 3. This is one idea. So, now if I subtract 1 from here, So what do I get? X must be less than equal to 2 and x must be greater than equal to minus 4. So here we are getting highest value to be 2 and lowest value to be minus 4. Okay. So this way also we can proceed with the question. Okay. But again the problem is, which is right? Is this right value or is this right value? Okay. So that is exactly why I have discussed this with both methods, because if you go by one method you will get one answer, if you go by the other method you may get another answer. So now tell me which of them is going to be right. So here let us work out with this. Suppose if x is okay, so let us check this. Suppose if x is minus 4, here x square becomes how much? 16. So if x square is 16 and if x is minus 4, then already this value is exceeding the 2 and y square and z square are non-negative values. So even after adding all of them you will not get 2 as the output. So which means this is actually wrong. So this cannot be done. Okay. So also if you check for this maximum value of 2, if I put x equal to 2 here, the output of x square is 4 and y square and z square are non-negative. So that means the value is still not matching. So this answer is also wrong, this is wrong, and this value is also wrong, this is also wrong. Now what has gone wrong with this? Why is it giving wrong answers? Because we have blindly assumed that x, y, z are invariably varying, indefinitely varying. So then what to do with such cases? So what to do with such cases? For that we need to use a different idea. Okay. Okay, so I hope you have understood these two methods and then we will conclude with the problem. First make a note of this. Okay. So now I will give you another method, which is the third method, by which we can solve this in a much better way, which is this. Here x plus y plus z is 2, so we can say that z is going to be 2 minus x plus y. Okay. So let us put it there and simplify. So what do we get? X square plus y square plus 2 minus x plus y whole square. So now if I simplify this, I get x square plus y square plus 4 plus x square plus y square, and what is the 2ab term that I will be getting here? Minus 4 into x plus y. Now here if I simplify, so there are 2x square terms, there are 2y square terms, there is minus 4x, there is minus 4y, there is plus 4 here. Okay. And again if I club all terms of x and all terms of y, what do I get? 2 into x square minus 2x, this is one term, and here 2 into y square minus 2y, this is another term, and there is one plus 4 there. Now to convert this into a perfect square, okay, so we need to add 1 here, add 1 here. So that means effectively I have added 4, I need to subtract 4 also. So basically this is going to give me 2 into x minus 1 whole square plus 2 into y minus 1 whole square. Okay. And this value, basically what have I done here? I have basically done this x square plus y square plus z square equal to this. So this is always a non-negative term, it comes out to be sum of two perfect squares, and it is given to be, this value is given to be equal to 2. So which will give us a condition like x minus 1 whole square plus y minus 1 whole square equal to 1. Now check for the minimum and maximum values of x here. Okay. So, if you observe this, geometrically it becomes a circle. Based on that you can analyze the values of x, or otherwise you can observe directly from here that this x minus 1 whole square must be less than equal to 1 and also this must be greater than equal to 0. So, based on this you can get the values of x. Okay. So, this way also you can solve this problem. Okay. So, I hope this method is clear. Okay. So, basically our main idea is to convert the given quadratic expression into a sum of perfect squares or a single perfect square. So, sometimes it may get converted into single perfect square or sometimes it may get converted into multiple perfect squares. So, whenever we get those perfect squares, we analyze their minimum and maximum values and we try to find the solutions. Okay. So, that way we can solve this problem. So, I hope you have understood the problem. Okay. So, if you quickly make a note of this, we will proceed with the next question. Wait. Okay. So, next question is this: find the minimum value of this expression. So, here I can proceed in two ways. I can either take x as my primary variable or y as my primary variable. If I take x as my primary variable, I have to collect all terms of x and try to convert that into a perfect square. Suppose let us say here I have taken all terms of x together. So, there is x square here, there are also two more terms with x. So, from them if I take let us say 2x common, so I will be getting 2 into x into y minus 3. Okay. And what are the other terms which are remaining? Plus 3y square minus 2y. These are the terms which are remaining. So, I have just taken that expression and I have simplified it. Now, looking at this, I am getting this idea that this looks like a square, this looks like 2ab. So, I have to add b square here to convert this into a perfect square. So, that means I have to also balance this with the extra term that I have provided. Whenever in any question, if I add a term, it is my responsibility to balance it. Now, looking at these three terms, I can just say that it is x plus y minus 3 whole square. Now, we need to understand the next terms. So, let us do some rough work and simplify this. So, here it is 3y square minus 2y, and let me expand this, I get minus y square minus 9 and plus 6y. So, this will come out to be equal to 2y square plus 4y minus 9. Also here if we notice, I can take 2 common and write it as y square plus 2y and I kept minus 9 outside. So, here if we add 1, this also becomes a perfect square. So, I have to subtract 2 here to balance it. So, basically here I can write 2 into y plus 1 whole square minus 11. Now, look at this. This is a sum of two perfect squares and this perfect square is always non-negative. This also is always non-negative. So, the overall value must be greater than equal to minus 11. So, we can say that the minimum value of this expression is always minus 11. But sometimes questions also come asking for the values of x and y for which this function is minimum. So, for that you need to equate these two to 0 and find the values of x and y. Okay. So, we can say that given expression is minimum when x plus y minus 3 is 0 and also y plus 1 is 0. So, this is possible when y is equal to minus 1 and x is equal to 4. So, these are the values for which this expression becomes minimum. What about maximum value? Because these are already non-negative terms, maximum value is infinity. Okay. So, this way we can solve this problem. Okay. So, I hope you have liked the solution. Come on, quickly take a snapshot. Okay, next. Suppose let us say there is a question here. So, here question is A greater than C, B greater than C, find the minimum value of this function. And here there is a condition that x is greater than minus c. Now recall our discussion on range of such quadratic functions. What is the discussion? X must vary indefinitely over all real values. But here there is a condition. So, equating this to y and putting discriminant greater than equal to 0 method fails here. Now, what to do? We need to search for other methods. Now, there is definitely one method in functions which is of rational functions, but there is one better method which is from the bridge course ideas, which is the AMGM inequality. So, here I will apply AMGM inequality and solve this problem. Now, because x is greater than minus c, this x plus c term is a positive term, and because a is greater than c, b is greater than c, we can also make sure that the other two factors are also positive, because x plus c is definitely less than x plus b. Because c is less than b, I just added x. Now, x plus c is already a positive term, so x plus b is also a positive term. Similar analysis can be applied for x plus a also, so which will make all three factors positive. So, here all numbers involved are positive. Now, to apply AMGM inequality, let me convert this into a better, smoother form. So, I will just write this function f of x as x plus c plus a minus c. This is my first factor. See, I just added c and subtracted c into x plus c plus b minus c divided by the denominator, which is the x plus c term. Okay. So, now further we can write this as x plus c whole square plus 2 into x plus c, 2 does not come, plus x plus c into a minus c plus b minus c plus a minus c into b minus c and whole divided by x plus c. So, let me give x plus c to each of these terms separately, because anyways we are dividing. So, we can divide each term separately. So, it comes out to be somewhat like this: x plus c plus a minus c into b minus c by x plus c plus a minus c plus b minus c. Okay. Now, this is anyways a constant term. So, this does not have any issue comes with these two terms. Now, how to proceed with this? Assuming that all these are positive terms, because we have already analyzed the sign. So, these terms are positive, every factor here involved is positive term. So, we can apply AMGM inequality on this. So, x plus c plus a minus c into b minus c by x plus c by 2. Basically, I am taking average of these two terms arithmetically. Arithmetically means by adding them. So, average by adding must be greater than equal to average by multiplication. So, root of x plus c into a minus c into b minus c by x plus c. So, here luckily x plus c gets cancelled. In fact, that is the main idea of this method. We have to make sure that it gets cancelled. Okay. So, that means we can say that this expression x plus c plus a minus c by x plus c, a minus c into b minus c by x plus c is always greater than equal to root of a minus c into b minus c. Okay. So, we already got a relation like this. Now, just add that term that is required, which is this third term. So, I can say that plus a minus c into b minus c. So, I can just add it over inequality, because it is a positive number, So it is valid. In fact, in addition, even if it is negative number, it's also perfectly valid. Okay. So this must be plus sign here. Okay. Yeah. So it must be plus sign, and here because this 2 has gone this side, so it becomes 2 here. So this RHS can be further simplified as root of a minus c plus root of b minus c whole square. Okay. So we can say that the minimum value of this entire function is this one. What about maximum value? Because these all the factors involved here are positive, highest value could be infinity. So we found the minimum value using AMGM inequality. Okay. So whenever there is any condition on x like this, then our method of equating that to y fails there. We have to modify our method and use different methods. Okay. So at this point we will stop today's lecture. We will meet again in the next lecture with new concepts and discussion. Until then, have a great learning day. Learning shall never stop.